Example. Dr. Position 52 degrees, and 48 minutes, north. 42 degrees, and 18 minutes, west, at UT. 1858 hours on the 1st November, the compass bearing of the Sun was observed to be 244 degrees. Find the error of the compass, and the deviation for the ship's head, if the variation was 4 degrees west. Using the Nautical Almanac, in the daily page, locate November 1, 2003. Under the GMT column, you will find the day. Locate 1800 hours. Commonly used in the Nautical Almanac is UT, actually, they are the same. Alongside right, you will find the corresponding value of the GHA, which is equal to 94 degrees, 6.0 minutes, and the declination, which is equal to 14 degrees, 27.9 minutes, south, of the Sun. Below the column, bottom left corner, you find the D value, which is equal to 0.8. Notice that the declination is increasing. So we must add the D correction value. In the increments and corrections table, locate 58 minutes. Under the second column, locate the corresponding value, which is 0 second. Alongside right, you will find the equivalent value, which is equal to 14 degrees and 30.0 minutes. Under the Sun and Planets column, in the V or D correction, locate the D value, which is 0.8, and you will find the value, which is 0.8 minutes. Solution. UT is equal to 18 hours and 58 minutes dated November 1, 2003. GHA is equal to 94 degrees and 06.0 minutes. Added by increment, which is equal to 14 degrees and 30.0 minutes. The result is the GHA, which is equal to 108 degrees and 36.0 minutes. Subtracted by longitude, which is equal to 42 degrees and 18.0 minutes, west. LHA or angle P is equal to 66 degrees and 18 minutes. Note: in solving arc, west longitude must be subtracted. In solving time, west longitude must be added. Unless it passed GMT. Declination is equal to 14 degrees and 27.9 minutes, south. Added by the D correction, from the equivalent value of the D, which is equal to 0.8 minute. The result is the declination of the Sun, which is equal to 14 degrees and 28.7 minutes, south. Let us now proceed to compute, by ABC method, using a calculator. We have all we need. Latitude is equal to 52 degrees and 48 minutes, north. LHA is equal to 66 degrees and 18.0 minutes. Declination is equal to 14 degrees and 28.7 minutes, south. A is equal to tangent latitude divided by tangent LHA. B is equal to tangent declination divided by sine LHA. C is equal to A plus minus B. Name A opposite to latitude, except when the hour angle is between 90 degrees and 270 degrees. Name B same as the declination. Name C according to the greater value. If it is in subtraction. But if it is in addition, name according to common. A is equal to tangent latitude divided by tangent LHA. Distribute the value. A is equal to tangent 52 degrees and 48 minutes, north, divided by tangent 66 degrees and 18.0 minutes. The result. A is equal to 0.578, south. Why is it south? It is because it is in the rule. Name A opposite to latitude, except when the hour angle is between 90 degrees and 270 degrees. B is equal to tangent declination divided by sine LHA. Distribute the value. B is equal to tangent 14 degrees and 28.7 minutes south divided by sine 66 degrees and 18.0 minutes. The result. B is equal to 0.282 south. Why is it south? It is because it is in the rule. Name B, same as the declination. C is equal to A plus minus B. Distribute the value. C is equal to 0.578 south plus minus 0.282 south. Can I ask you one question? Okay, what is the value of C? And what is the name? Pause the video for 10 seconds. C is equal to 0.86 south. Let us now solve the azimuth. Cotangent azimuth is equal to C multiplied by cosine latitude. Name the azimuth, same to C, and the angle P / meridian angle. Distribute now the value. Cotangent azimuth is equal to 0.86 south multiplied by cosine 52 degrees and 48 minutes north. The result. Cotangent azimuth is equal to 0.51996. Azimuth is equal to south 62.5 degrees west. You might wonder, where did I get the prefix south and the suffix west? Well, again, it is in the rule. Name the azimuth, same to C, and the angle P / meridian angle. Lastly, where this figure came from. If we have both, have the same model of calculator, Casio, FX991MS, SVPAM. Please input 0.51996, then press equal sign, press shift, press tangent, press 1, press A, B over C, press answer, then press equal sign. A friendly advice, familiarize your own calculator, you will be using that for your entire journey of this discipline. The azimuth is now expressed in quadrantal form of reading the compass, which is south 62.5 degrees west. It is belong in the third quadrant. The formula in expressing it into new form of reading the compass is that azimuth is equal to 180 degrees added by the angle. It goes into this equation. Azimuth is equal to 180 degrees added by 62.5 degrees. The result is azimuth, which is equal to 242.5 degrees, true. Let us apply now the compass bearing, which is 244 degrees. The difference is the compass error, which is equal to 1.5 degrees. If compass is best, compass error is west. Apply the variation now, which is 4 degrees west. The result is the deviation, which is equal to 2.5 degrees. If the compass error is less than the variation, reverse the sign of the variation. Variation is the error of the locality. It is measured east or west from the true north. The point reached by the variation is the magnetic north. Deviation is an error from the outside forces that causes influence to the instrument. It is measured east or west from the magnetic north. The point reached by the deviation is the compass north. Compass error is equal to variation plus minus deviation. Familiarize this, for you will not be weary in correcting and uncorrecting the compass. Remember, the Viking mariner don't cry. When plotting bearings, everything starts from the true north. In this example, let us begin to plot the variation, for we will be able to plot the deviation from the magnetic north. Compass error is always measured from the true north to the compass north, and we will be able to plot the compass bearing and the true bearing. Thank you for watching. Please subscribe, and click the notification bell, for you will be updated, for our next upcoming video.